Okay, let's do the quiz first. This is Kevin's quiz because he didn't take it. Okay, if two triangles are similar, then all the angles are, yep, I'm just going to do the symbol. And the corresponding sides are what? Yes. I was very nice and gave you half points if you said similar, because at least you didn't say it was congruent. But they are proportional, not similar. The triangles might be similar. So if I talk about like a triangle, I can say like this side is proportional to like this side. Yeah, but these, if they all have proportional sides, then we have similar side, 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 and then those similar triangles. So like figures are similar. Yeah, sides are proportional. Okay. Describe a similar transformation to prove that they are similar. You could have gone from big one to small, small one to big. It doesn't really matter. But you need to put down details. A lot of you guys got points off because you didn't give me the center of dilation for your dilation at the end. So if I'm dilating this and you don't tell me that it's A, then I can just dilate it from B, or I could dilate it from the origin, but then the shape would be like all the way up here if I did it from the origin. And then that makes everything else off. So if I reflected that over the y-axis, then it would be like over here, and it messes everything else up. So could have said reflect this one over x equals -1, because that is the midpoint line of those two figures. Translated it, okay, I'll just move this point. Would have been here. Then I would have translated it up 1. And then it was the dilation from point A with a scale factor of what? Oh, yeah. Should have been 1/2. If you did it the other way, it would have been 2. Okay. Let's flip it over. Okay, half of you talked about, this one is similar. Half of you talked about angle-angle similarity. The other half talked about a dilation at point Z. I was nice about the dilation. I kind of want you to focus on the angle-angle theorem about similarity, but I also did like the dilation. So I either gave you a full point for that if you gave me the center of dilation at Z, or if you only gave me half that. Okay. Were these similar or not? Thumbs up for yes, thumbs down for no. Sunny, can you tell me why? So these all have to add up to what angles? What's, yep, 180. So when I did the math, this was not 49. It's not 49. That's not when we add these all up. So 53 plus 61 plus, we'll call that x because I have x there. That x was not 41. So we did not have angle-angle similarity on that one. Okay. How did we do on 4? Some of you guys are confident in it. Can anyone tell me the proportion they used? Say a little bit louder. 9/15? Can you tell me why you picked 4? No, x over 18? You're right. Okay, because the corresponding sides of this entire figure. So those are both the hypotenuse. Yeah. So when we added this one, 9 and 6, we got 15. So now we're talking about the other sides. So now we're talking about 9 and 15. So we're talking about corresponding sides of the triangle. What is my next step, Anna? What do I always have to do at this point? Okay. Cross multiplied, should have got 15x equals 162, and then x equals 10.8. Yeah. Okay. How do we like word problems? Yeah? No? Does anyone want to sketch up on the board what they drew? No? I want to see everyone's drawings. Okay. Okay. Remember, we're talking about shadows. Shadows on ground. Rose, you want to sketch it? Yeah. You did a 3D image, which was surprising, which is not. I'm gonna go 3D.
Mardella's like, I reread this thing multiple times. I did not see 6 feet tall. So I assumed he was 5.
Okay. Let's sketch it. I also like that, but you forgot that the standing right. It is also right. I still got right. Yeah, you still got right. Okay, let's go through this. We have a 6-foot tall person. This is my person. Okay, I was just gonna draw a line. I know, I was just gonna draw a line. Okay, this is my person. He is 6 feet tall, or this person is. Standing next to a flagpole. Next to. Flagpole. Right there. Right next to it. I'm standing next to it. I'm standing next to this thing. I'm hugging the flagpole. Yeah, okay. 6 feet. Perpendicular to the ground. There's my ground. Person is casting a shadow of 1.5 feet long. A shadow is on the ground. So this is a shadow of this person. Okay? 1.5. Yeah? Okay. I'm just going to connect these 2 points. We got a triangle. The flagpole is also casting a shadow of 5 feet. So this entire length of this shadow is 5 feet. Now this is the sun. Whatever. That's a bad sun because I was looking up on the board. So these angles are going to be congruent, okay? These are similar triangles right now. Can anyone tell me the proportion that they did for this problem? X over 5. 6 over 1.5. So this height was primes x. Oh, all right, that height was primes x. So we got proportional triangles, very similar to the one above. We are looking at the corresponding sides. Should have got x equals 20 for that after we cross multiplied. Yeah. Okay. That is it for the quiz. Do we have any final thoughts or questions on it? Okay. Then let's go over to the team test. Nope. You guys did great on the team test. Okay. Honor. I put it in as less of a point because you guys used your notes, so it impacted your grade less. Elijah, Sunny, and Odelia, you were in a group, right? Did you guys use notes? No. There was another group that didn't use notes, right? Klein, Rogue. Did you guys use notes? You did? Or didn't? Jonah. Okay, I didn't put it down for you guys, I think. Yeah. Okay, well, I put it down as you didn't use notes because you didn't say it. Okay. Liam, can you read me the top for me? What is my first blank? Hypotenuse. Okay, we're talking about a right triangle. So this is my right triangle. 90-degree angle. Altitude is what to the hypotenuse? When I draw my hypotenuse, what angle do I create? When I draw my altitude to my hypotenuse, what angle? A right angle, yes. So it's going to be perpendicular. It creates two smaller triangles that are similar to the original. Okay, guys, there will be a definition one on the test, okay? I like definition questions to start it off. So it's going to be on there, just so you know. Okay. Okay, there are many different ways you could have done this. Can anyone tell me the way that they used? Yeah. I love that Elijah said the scale factor, the center of dilation, which shape we're starting with, which one we're changing. Reflection. I'm giving you a hint. Reflection is the little r, guys, and then we say our line. Okay? If I have a big R, that's rotation. And then you give me like 90 degrees around the origin. Dilation is the scale factor and my center. And then we all know translation, the X and the Y. Now, when I write this, let's say I have 3 different ones, and I state which one I'm changing. A, B, C, D. Which one goes first? Okay, yes, in this problem we did reflection first, but that's always going to be the one on the left. So it's on the right. Go right to left when we're reading this. Okay? You can write it this way, or you can write it out in words. Either one is totally fine. Okay. Do we have any questions about that problem? Okay, there's different ways you could have written it. Okay. A, not similar. If you wrote a proportion, you would have saw that the scale factor is not proportional on both sides. These are parallelograms. We cannot use angle, angle, side, 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 or side, angle, side, because these are not triangles. These are parallelograms. Okay, what about my other side? Similar, why? Scale factor. Side, side, side. What was the last one, Elijah? Yeah. So I accidentally gave you the 2 angles. So you could have just looked at it and figured that out. So, but I was very happy if you did this one. Side, 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 or scale factor. That's what I wanted you to do. Okay. Moving it down. A lot of people were a little tripped up on 4A. You might have forgotten or didn't see these. You got little marks right here. What do these tell us? Yep, congruent. So what theorem pops into your head? Congruent sides. We only had one with congruent sides. I want you to look back in your notes. Look back in your notes. What theorem are we talking about right now? Congruent sides. I have a length, and I divided it into 2 different, nope, I divided it into 2 different equal segments. What am I thinking about?
It means this is the bisector.
I have a segment. I cut it into 2 equal lengths. What is what is J? If I have F, H, what is J?
J is in this middle.
Yes, the 2, 2. Okay.
off my. You're still trying. Stop trying. Enough child. Oh, I hit a funny ball.
Okay, Rodelia's gonna read out to us.
Triangle makes segment theorem. If a segment joins midpoint of two sides of a triangle, then the segment is parallel to the third side and is half as long. Yeah, half as long.
Yeah, that's great. So that gave us these. But if these are both congruent, what can we do to them? Yep, set them equal. So we had y plus 12 equals 2y minus 5. Can I do it with the other sides as well? Yeah. So I got 3x plus 7 equals 4x minus 1. So x would have been 8, y would have been 17. All right, what about C? I'm gonna go over C. I got two parallel lines. What theorem am I thinking about now? So we're thinking about side splitter. What is my proportion then?
Over 4.
Elijah, can you give me it? So this is the left side of the triangle. This is the right side. And then x and 12 are on the same level. If we're looking at it like that. Same level. 4 and 5 are on the same level. So that should have been our proportion, and x should have been 9.6. Okay, last two. What are we doing here? What is this telling us?
Angle bisector.
Yes, angle bisector. We have two congruent angles right there. So we're talking about angle bisector theorem. So that's saying this side is proportional to this side proportional to that side. So what was my proportion here?
X over 13.5 minus X.
Okay, you can write it like that, sure.
And then 8 over 10.
Okay, could have also written it as x over 8 because we're talking about one triangle to the other triangle. Technically, we would have gotten the same answer. I would stick to this one though. Okay. Do you want me to show you the cross multiplication or we're good? Thumbs up if skip it, thumbs down, need to do it. Okay, skipping it. X equals 6. Exact same problem over here. Riley, can you tell me your proportion? Over what? 28? Did everyone get the same thing? No? Yeah. So I need this segment right there. So I need to do 28 minus x to get that. So minus x. That should have been your proportion. And then x equals 12.9. Okay. How do we feel on this page? Good? Okay. Flipping it over. Find the length of the altitude in RST. What is the altitude in this triangle? Vincent. What's the altitude? What line? Yes, SU. That one right there. So using geometric means, or however you want to do it, if you want to do corresponding sides, what was my proportion? So we're talking about corollary 1 right now. The altitude is the geometric mean. So, yep. So SU is the geometric mean of the two lengths that make up the hypotenuse. So when we had A over X equals B over, I was wrong. A over X with X over B. What is our X in this situation? SU, because that is the geometric mean of the other two. So we can do 4 and 12. If you switch these two, it doesn't matter. So I cross multiply it. Got SU squared equals 48. Then you square root both sides. What was SU? 6.9 or 4 rad 3. Either way. I don't care if it's either way. Okay. After reflection of the line, A line, A prime, B prime, C prime is the image of ABC. Explain why triangle ABC is congruent to triangle A prime, B prime, C prime. I want multiple people to share out what they wrote. Fine?
And you said that triangle, the motion is just a rigid motion, because it's a reflection, which means it doesn't change shape or size.
I like it. Someone else? Sophia, what did you write? Oh, you guys want to see the group? Okay. Who is not in that group? Anna, you want to read out yours?
It's congruent because reflection is a rigid motion, so it won't change size or angles.
Okay, so that was those two groups. What are my other groups? Okay, Elijah, what did your group say? Okay. Well, what did your group say? Why is that all the groups? Yeah. And angle measures, yeah. So she said rigid motion. Can anyone tell me the other two things that are also rigid motions? What is not a rigid motion? Why?
Because it changes size.
Yeah, great. And preserves angle measure. That was great. Oh, back to word problems, our favorite. But this was supposed to be building. Okay, who sketched an image? Okay, I want to see this image. Compare to the person next to you. I feel like you want to go 3D.
Why? I don't like that.
You did a lot better on this. Oh, yeah.
Dear. As if that made it better. The shadow wouldn't even be like that. The shadow would be. Because there's multiple lights. Bro, I need to stop teasing.
Okay, you guys all had the same image, most of you. So this is my building. Call it B. This is the ground. Building is perpendicular to the ground and casts a shadow of 16.6 meters. Where is my shadow? Is it that? No. It is perpendicular to the ground. So this is my shadow. So that was 16.6 meters. Tim stands at distance 12.45 from the building. So that's my person. This is away from the building. So that should have been 12.45 meters. He is 1.65 meters tall. What is my proportion to get the building's height? Okay, that's the big triangle. What's my small triangle proportion to it?
1.65 over 4.15.
Can you explain to me how I got 4.15?
I just took the shadow of the building, which is 16.6 feet,
Mm-hmm.
subtracted by the distance of the person standing, which is 12.4.
That's what we should have gotten for that distance right there. Okay, x would have been, or b in this case, 6.6 meters. Ooh. I really hope that we all put meters on the test. I didn't mark it off this time, but let's label it. Okay. Some of you realize that we did this exact problem word for word in the notes. I didn't even know that. This question is actually from a New York State Regents test. Do you know what the New York State Regents are? Okay, so at the end of the year for Algebra 1, Geometry, and Algebra 2, every single kid in high school has to take a New York State Regents test. So they all get the same test, and they all get graded on the test. It's like a 2-hour long test, and it's really long. So I was trying to see how you guys do with Regents test. This is the exact wording. Well, I accidentally gave you this problem in the notes too, which I did not realize that. So, which one did we do first, A or B?
I did B. The second one.
Okay, give me a 1 if you did A, give me a 2 if you did B. First, like which one did you do first? 1 if you did A first, 2 if you did B first.
I did B.
I did B. I know, because
Sunny, we did B.
if you did B first, it was actually faster. But you could have done A first as well. But A would have taken much longer. Okay, I think most of you did B first, so let's do B first. BIM? What? I'm confused. Okay, let's label it. KG is 9. IG is 12. Oh. Okay, so how did we get GM? Same thing as on the other page, except it's a little bit mixed around. We're talking about corollary 1 right now, about the altitude and the 2 lengths of the hypotenuse. So what was our proportion? Yep, over 12. 12 over 9. Does anyone have any questions about how we got that? Okay, no one does. So when we cross multiply, what do we get, prime?
16.
Yes, x equals 16. So we know that this is now 16. Okay, IM. We're looking for this right now. I'm going to call this y, so I don't have to keep writing that. So now we're talking about corollary 2. We're talking about these sides being proportional to these, and this one being proportional to that one. What was my first step? Okay, prime says y over 16. What's on the other side?
Oh, 15. Oh.
What am I missing? I'm missing this length and this length right now. I need to figure out one of them. What can I do? Say it louder, Elijah. Theorem. Yep. So what is that? Okay, I'm gonna write down first. A squared plus b squared equals c squared. We're gonna talk a lot about that next week. Like, you're gonna be so annoyed by looking at that theorem over and over again next week. We're gonna prove that theorem next week. Okay, did you do this to the big one? Oh wait, medium one or the small one? Okay, so you could have skipped this proportion and just done that and gotten IM. That's why you could have done GM first. But let's do it with the small one so we can get our proportion. So this would have been what? A is our, okay, I'm going to tell you, is 9 squared plus 12 squared equals c squared. You should have gotten 15 equals c. That's actually a triple, which we're going to talk about on Tuesday. So this length was 15. So prime, finish your proportion.
Oh.
You would tell me.
15 over
15 over 9. So we looked at medium-sized triangle, this one, in our small triangle. So this one. And I cross multiplied, and I should have gotten y equals 20. Or you could have just done this theorem with these sides. That would have been fine. You should have gotten the same answer as well. Any thoughts on the team test? Okay. So you all should have finished your note card. So are we ready to start it today? Yeah? Okay. I already printed it out. I'm ready to go.
We started our note card.
Yeah? Okay. I know. So do you want me to just give you time to work on your note card?
Please. I need that.
Or you didn't hear the or. Wait 1 second. File open. Oh. What do we need a review of the entire unit?
Maybe just split.
Where is it? Okay, well that's not there. Okay, it sounds okay. Who wants a review of the entire unit? Thumbs up. If you want to work on note cards, thumbs down. Okay, note cards it is. Okay, remember this test, the real test is different from this one. So don't just copy and paste every single problem onto your note cards. Copy and paste the big ideas, which is our theorems. No, it's not. We can do that. Want to do pre-calc? No. Okay, I'm going to come around. If you have any more questions about the practice test, please ask me.